Have you ever ridden on an escalator, placed your hand on the handrail, and noticed that your hand was moving faster than your feet? If you grabbed the handrail and didn't let go, you might even eventually be pulled over. This isn't a design flaw. In fact, escalators are designed with faster moving handrails in order to increase how long they can be used for. But first, some of you may be confused. Handrails on escalators don't always move faster. In fact, sometimes handrails can move slower or at the same speed as the moving steps. If you use one escalator regularly over time, chances are that the handrail will change how it moves relative to the speed of the steps too. This all comes back to the same issue and is in fact exactly how the escalator is designed. To answer this question, first we need to address how handrails and escalators are designed. Escalators are essentially just a ring of steps connected to a motor with gears. That motor turns the steps, but it also turns the handrails. The rubber handrail on the escalator is essentially one giant rubber ring. It flexes as it rolls around the escalator system. The handrail and the escalator loops don't need to be the same length or circumference to work together properly. All that matters is that the rail and escalator steps move at the same relative speed on the straight portion where the riders are standing. While the escalator steps are driven by metal gears, the handrail is driven by a smoothish ring, which moves the handrail along through the use of friction. This drive method of friction is at the root of why handrails can move at different speeds. Over time, the friction wears the rubber handrail out and stretches it, making it slightly longer than it was originally built. But you might be thinking, that's why a handrail might be slower. Why then would it ever be faster than the steps? Because that's how engineers designed it. Some escalator codes have about a 2% tolerance for the difference between handrail speed and escalator steps. This means that engineers actually design the handrails on new escalators to move 2% faster at the beginning of their life. They start out within tolerance of 2%, eventually getting worn down to move at the perfect speed. And then finally, at the end of the handrail's life, it moves 2% slower, right before it needs to be replaced. If the engineers simply built the handrail to run at the perfect speed to start, then the handrail would only have half the lifespan. By designing the handrail to move 2% faster at the beginning of its life, engineers are able to double the potential life of any given handrail. It's also important to note that the 2% faster or slower metric we've been mentioning is a general standard. Some countries or municipalities will have larger or smaller escalator standards. So, to answer the original question at hand, why does the handrail of an escalator travel faster than the steps? Well, it's because that's exactly how engineers design them to function at the beginning of their life. If you ever get on an escalator and the handrail is moving much slower than the steps, even jerking around, then you know that escalator is near the end of its service life and probably needs to be repaired. Now you might think twice about riding on an escalator with a slow handrail.